This presentation describes a simple class in C++ and describes the code that will define the class, define the data members of the class, and some of the more basic functions that are associated with a class. The code that defines the class has this syntax. It starts with the keyword class, tells the compiler that we are defining a class in the code that comes up, and that's followed by a name for the class. This has to be a valid C++ label. And if you were programming in an organization that had requirements for name conventions, you would need to follow the convention that is established for naming the class. The definition of the class falls in between the opening and closing curly braces, and inside this class there are two kinds of declarations. There are declarations of the things that are public. These are data members and functions that can be accessed by the program outside of this class. And then there are the private declarations. These are variables and functions that can only be accessed from within the class itself. And a semicolon has to follow the closing curly brace. This is the definition of a simple class. It starts with the keyword class. That tells the compiler that we are creating a class of objects, and the objects I want to describe with this class are rectangles, so that's what I've chosen for the name of the class. And the definition of the class is inside the opening and closing curly brackets. The first declaration in the class are the private members, and I'm declaring the data members of the class as private data members so that only member functions inside the class are permitted to access or to modify these values. The data members of the class are the pieces of information that describe the class. Since I'm describing a class of objects described as rectangles, I'm going to use the width of the rectangle and the height of the rectangle as the data that describes the rectangle. Both of these are type double numbers. So in this simple example, I'm using two type double numbers to describe the class of objects, but you could use any number of pieces of data using the standard C++ data types to describe a class. What follows are the public declarations. Inside the public declarations, I'm putting the member functions that can be accessed and called from the main function or from other functions inside my program. The first two of the member functions are called constructor functions because they are called when the object is created from a function call inside the main function. The first of the constructor functions, to start with, the name of the constructor functions matches the name of the class. That is how the compiler recognizes these as constructor functions. So the function name is the same as the class name. The empty parentheses indicates that this function takes no parameters, and the function itself is written inside the curly braces. And since this is a short function, I've written it all together here on one line of code. Now, in this case, when this function call is executed, a member of the class rectangle is created, and then the data member width is assigned a value of 0, and the data member height is assigned a value of 0. If you can write this constructor function with empty space between the curly braces, and then when the function is called, it will still create the object, but it will not make an initial assignment to the values. Although it seems to me it's a good idea to assign values to something when it's been declared. This is the default constructor. The second constructor function, it also starts with the same name as the class. That's how the compiler knows that it is a constructor function. In this case, though, the function takes two parameters. It takes a type double number that goes into the local variable w, and it takes a second type double number that goes into the local variable h. And the function itself, since it's short, I've written it in this one line of code. It simply takes the value that is passed to the local variable w, and assigns that to the width, which is a data member of the class. And it takes the value that is passed to the local variable h and assigns that to the data member of the class known as the height. And in this way, you can create an object of the class rectangle with a particular width and height. The next two functions in the public function declarations are called accessor functions, because with these functions we have access to the data members. They are written in the same form as functions that you're familiar with. They're both very similar, so I'll describe the two functions together. They start with the return type. Both of these functions return a type double value to the function call. Then what comes next is the name of the function, and the name has to be a valid C++ name, something that seems appropriate. I want to return the width and return the height of the rectangle, so I name the functions getWidth and getHeight. Both of these functions, or I should say neither of these functions, takes a parameter, so the function call does not have a parameter. The constant keyword will declare this function as returning a constant. So this indicates that the function does not modify the value, it simply returns the value. And the function itself is written inside the curly braces, and it's a very short function, so I can write it all in one line. And it's simply the return statement followed by the data member that is being returned to the function call. So return width will return the value of the width data member, and return height will return the value of the height data member. This is the main function that exercises the class that I've just described. It's a simple function. It looks like all of the other main functions that you've written. This second line inside the main function, rectangle box 1, that is a declaration of an instance of the class known as rectangle. So it creates an object of the class rectangle, and the name of this object is box1. You can give these objects the variable names that seem appropriate, so I simply called it box1. And this is a function call to the default constructor function. So when the line of code rectangle box1 is executed, it is a function call to the function inside the class box that it has no parameters, and it simply it sets up memory space, associates that with the name of the object box1 and associates memory for the width data member and the height data member and assigns an initial value of 0 to both of those data members. This next line that I've indicated is also a function call to the class, the rectangle class, and to the constructor function, but this is the constructor function that takes parameters. And since in parentheses after the name of this object, which I'm calling box2, in parentheses I have the two type double values that are being passed to the function 1.2 and 3.4, and it's a function call to the constructor function that takes the two type double parameters. So when this function call is made, the value 1.2 is assigned to the local variable w, and the value 3.4 is assigned to the local variable h. And then inside the constructor function, those values are assigned to the width data member of the object and to the height data member of the object. See, the values 1.2 and 3.4 are sent to the function by value, and the values are assigned to the two data members. The next bit of code prints out some of the information. I start with the address of the object. The ampersand operator returns the address of the object box1, so it will print out the address number where this object is located, and then it tabs over and it prints out a bit of text, and then there is a function call to retrieve the width of box 1 from the rectangle class, and that function call has the form of the object name and then the dot operator and then the function name and then the parameters inside the parentheses. So this function call follows that format. Box 1 is the object name, then the dot operator, and then get width is the function name, and then it takes no parameters, so there's the open and close parentheses. That is a function call to the accessor function that returns a type double. Its name is get width, takes no parameters, and it returns the width of the object as a constant. And in this case, when that number is returned from the function call, it is simply printed onto the screen, and then it tabs over, and there's another function call on the line right below it to retrieve the height of the rectangle, and it's very similar to the description for retrieving the width. When this bit of code is executed, this is what appears on the monitor. I have successfully declared a class of objects known as rectangle. I have instantiated two objects of that class. I've declared the variable name box1 as one rectangle, and it was given the default width and height of 0, and I declared a second rectangle called box2, and I specified numbers for the width and the height, and those have been assigned to the data members, and I've successfully retrieved those values. So both the width and the height are type double numbers. So the memory space required for these objects is the memory space required for two type double numbers.